In this video, we'll go over the last topic of the unit, which is linear quadratic systems. So it's very similar to the idea of linear systems, where you have multiple lines and you're trying to solve for where they intersect. But for linear quadratic system, you have a line and a parabola. But the idea is the same. You want to solve for the solutions. If you're given the graph, for example, of the line and the parabola, you want to find out where they intersect. So hopefully, actually, before we start to do the algebra, you want to visualize the three different possible scenarios, because really things can happen when you graph a line and a parabola in terms of the number of points of intersection that can occur. So give yourself a minute or two and try to imagine the three different possible scenarios. Okay, so hopefully you've given yourself some time and you have the three scenarios. So the first scenario is two solutions, okay? Or you can say 2 points of intersection. So how can you do that? Let's draw our classic parabola here. And then we're just going to draw two solutions, something like that. All right. Okay, the next situation, next possible scenario is one solution. And by the way, for the previous scenario, this line where it intersects the curve at two different points, that line's called the secant, okay? And we're going to study that later on in advanced functions. So try not to forget the name. The secant line is, it's going to be, we won't spend too much time on it, but yeah, I would argue actually you've seen the secant line in grade 9, okay, when you talk about change. But you know what, let's just move on and talk about the next scenario, which is the tangent line. So there's one solution here. So this one's tricky. It's very tricky to draw, but I will try my best. Let me just think. 2x, so 2 times 1 is 2. Okay. So I'm kind of using a bit of calculus to draw the tangent line, but you know what? At home, you're doing this, you can just draw it. You can just try your very best. But I did use some algebra to help me graph the line as best as I can. But at the same time, I'm not the most artistic individual, so anyways, just try your best and intersect the curve at one point. No one's gonna be able to do it perfectly, but just do your best. So you can have two solutions. You can have one solution, or you can have no solutions. All right, so I'm going to be a little wild. Let's draw the parabola over here. So let's talk about the step pattern. 2, so it's 2, 6. So 1, 2, 3, 1, 2, 3. All right. Okay, so there's your parabola. And let's say there. No solutions. Okay. Some students, they say this, and they say no solution. All right. So we have our three different scenarios. Let's do the algebra now. For example 1, you have your parabola with f of x equals x squared plus 7x plus 2, and you have your line g of x equals x minus 3. So let's find out where they intersect. F of x equals g of x. So when is f of x equals g of x? X squared plus 7x plus 2 equals x minus 3. Let's set equal to 0 because what do I have here? I have a quadratic equation. All right, set equals 0. You have two choices, factor or quadratic formula, but it is factorable, so definitely factor. All right, so x is -5 or -1, which means if we're talking about the points of intersection between the line and the parabola, the x-coordinates for the points of intersection are -5 and -1. But having the x-coordinates is great, but I want to also find the y-coordinates. Now, to find the y-coordinate, you can use the parabola or the line, but I'm going to use the equation of line because it's simpler. So I'm going to find g of -5 and we're going to find g of -1. All right, awesome. So when x is -5, y is, so therefore points of intersection are, so -5, -8, and -1, -4. And that's it. So that's how you solve a linear quadratic system. Set f of x equals g of x to find out where they intersect. And once you set them equal to each other, you basically have a quadratic equation. Solve it by factoring if possible. If not, use a quadratic formula. Once you have the values of x, you can solve for the output values. You can solve the y values. All right, you know what? Let's practice that one more time. Because if this was on a test, it's like a 3 or 4 mark question. So let's do one more practice shot. Okay, so once again, f of x equals g of x. So you have x squared plus 10x minus 30 equals 14x minus 9. So minus 4x. This is going to be minus 21. Ooh, nice. Factorable again. So the x coordinates for the points of intersection are 7 and -3. So once again, I'm going to use the linear function. So g of 7. Let me just quickly check that. Yep, 89. And g of -3. Oops, -3. Let's check that too. -51. Therefore, points of intersection are, what is it? 789 and -3, -51. One great way to check is find f of 7 and find f of -3. Okay, let's try it out. -3, oops. All right, so when x is -3, f of -3, bam, -51. I'm feeling great about that. So -51 is on the parabola and on the line, so guess what? That's a point of intersection. And you can find f of 7, but sure, why not? There we go. So 789 is both on the line and the parabola, and I'm feeling good. And you might be thinking, is there a third point of intersection? Of course not, you silly Billy, because the best case, well, not the best, but it has 0 solutions, 1 solution, or 2 solutions. There is no third solution possible when we're talking about a linear quadratic system. All right, so sometimes on a test, we change up the question. We don't ask you what the points of intersection are, but we ask you how many times they intersect. So I can argue, I guess, that the question is a little less work. So once again, we're going to start off by letting f of x equal g of x. Okay, and then set equal to 0. But be careful. You're not going to solve this equation. All you're going to do is find the discriminant. Because like I said, you don't care what the points of intersection are. You want to know how many there are. So we want to know how many real roots are there for this equation. So b squared minus 4ac. So I can already see that it's positive, but I'm going to crunch it out. So it's 12 times 9 is 108, 108 plus 25. That's 133. So what does that mean? If the discriminant is greater than 0, okay, that means this equation will have two unique real roots, which means there are going to be 2 points of intersection. Okay, the discriminant strikes again. Very useful. All right, so let's do this one. How many points of intersection are there between f and g? So once again, we're not asking what the points of intersection there are, or what exactly are the points. We're asking how many points there are. So f of x equals g of x. Minus 2x plus 1. Let me triple check. Okay, looking good. So what's the discriminant? Ooh. Really? Nope, no, it's not what I thought it was. So this is 4. 4 minus 8 is negative 4. So since the discriminant is less than 0, therefore 0, or yeah, you can say no points, 0 points of intersection. You know, I prefer no points of intersection better. No points of intersection between f of x and g of x. Okay, see, discriminant, very nice. All right, last question. If a line with a slope of 4 has 1 point of intersection with the quadratic function f of x equals half x squared plus 2x minus 8, what is the y-intercept of the line? All right, so let's say let g of x equal 4x plus b. Okay, so I know the linear function, I know the slope, but I don't know y-intercept. So I'm going to let the equation of the linear function be g of x equals 4x plus b. So f of x equals g of x, which means half x squared plus 2x minus 8 equals 4x plus b. Let's set equal to 0. Okay, so let's find the discriminant here. Negative b squared minus 4ac. Now be careful, c is negative 8 minus b. Okay, so we have 4 minus 2 minus 8 minus b. Let's just keep simplifying this, why not? All right, now there's one very important fact that I haven't used yet, which is 1 point of intersection. There's 1 point of intersection between the line and the parabola. So if that's the case, I take the discriminant, which is equal to 20 plus 2b. So since one solution, therefore, discriminant is equal to 0, right? So that means 20 plus 2b must be equal to 0. And that will enable us to solve for b. b is negative 10. Therefore, y-intercept of line is negative 10. And of course, you can sub it in and check. But the answer is negative 10. that will give you 1 point of intersection between the line and the parabola. I'm just going to quickly check. So if this is 10, this is 2. So this is, oh, sorry. Yeah, 2. So if that's 2, that's 1, 4, 4. Yes. Yep. That, because it's a discriminant of 0, that means this has to work out to be a perfect square trinomial. And I did in my head, subbed it in for b to be negative 10, and it does work out to be a perfect square trinomial. This half was throwing me off, but I just have to multiply both sides by 2. Anyways, you could check it yourself. Okay, so that's linear quadratic systems.